Welcome back, class. So today we're going to look at graphing our constant of proportionality. So we have recently been talking about unit rates. We know that unit rate means for one, and so constant of proportionality means the same thing. But remember, when we're discussing that unit rate in a table, graph, or equation, it is referred to as a constant of proportionality. Don't let that fool you, okay? But today we're going to look specifically at graphing. You should have out your paper and pencil. I expect that if you see it on my screen, you do write it down on your own paper. You may pause the video at any time if you need more time to write something down. So the first thing that I want to look at is some examples of proportionally graphed data. I want you to look at the graph on the left, and I want you to look at the graph on the right. Okay, I want you to just take in their characteristics, what you think. Whenever you see these two graphs, what do you notice? What do they have in common? Okay. Let's look at some examples of non-proportional data graphs. So I want to look at these two graphs here, and I want you to think about the graphs that you just saw and how are they different from the graphs that are currently on the screen. Okay, so if you need to go back, you can pause the video and go back and compare the two. Okay. So what did you notice? Okay. What did you notice whenever you were looking at the graphs of proportional data and the graphs of non-proportional data? And I want you to make sure that you write this down. Okay. Graphs of proportional data must, very first thing, they must pass through the origin 0, 0. Okay. So remember that, let me go back here. In this one's a better one. In this particular graph on the left, what would be 0, 0 would be down here. Okay, so we're talking 0 time, 0 distance. Over here, though, the origin, remember, it's that spot in the center where that X and Y axis will actually cross. Okay. So that's the first thing. It must pass through the origin, and we notice that on both of our examples for proportional data, that they both either started at 0, 0, or they went directly through the origin. If we look back here, notice that the graph on the left actually starts at 0, 10, and the graph on the right looks like it starts at 0, 1. Okay. The second thing that graphs of proportional data must have is that it must form a straight line. So these are the two things. This is what makes a constant of proportionality the constant of proportionality for a graph. You are able to look at a graph and identify whether or not it actually has a constant of proportionality by these two things. It has to pass through the origin and it has to form a straight line. If it does not do both of those things, then it cannot happen. So please make sure that you have this written down in your notes. If you need to, you can pause the video here. Make sure you have this down. I would go through and I would also sketch the examples of proportional data graphs and the non-examples. So pause the video if you need to, and then you may resume whenever you have those down. So let's look at our first example here. So in the top left-hand corner, I have briefly written a scenario. Since you're watching the video, I didn't want to write out the whole problem. And the problem says that Nico works in his aunt's shop and she pays him $8 for 2 hours of work. So every 2 hours that he works, he earns $8. Okay. And so the question actually asks us to not only identify our constant of proportionality, but to create a table based upon our constant of proportionality and then to actually graph those points on the coordinate plane. Okay. So let's go ahead and do that here. It tells us that he earns $8 for 2 hours. So remember that we had to start at 0, 0. Okay, so if he works 0 hours, he should have 0 pay, correct? And we know that after 2 hours, he earns $8. And let's say that this is 1, and we'll go up to 3. Okay, so 0 hours, 1 hour, 2 hours, and 3 hours. So if I wanted to identify my constant of proportionality, remember that I have my proportion set up. So I've got $8 for 2 hours, and I want to know how much money that would be for 1 hour. Put the H's there. Remember, you can always cross multiply and then divide. So I get 2x equals 8. divide both sides by 2 so that x would equal 4. So this tells me that every 1 hour equals $4. Okay, so if I work 0 hours, I make 0 pay. 1 hour, I make $4. 2 hours, I make $8. How much money should I make after 3 hours? If you said 12, you are correct. Okay, so what's awesome about this table is that this is actually our x and our y coordinate planes, or our coordinates, I'm sorry. So our hours would go down here on the x-axis, and our money would go on the y-axis because it is dependent upon how many hours we work. So let's go ahead and graph our points. So we have 0, 0, 1 and 4, 2 and 8, and then 3 and 12. Okay, so notice our points. We start at 0, 0, and we go in a straight line as best as what I can draw it. So yes, our data is proportional, and we have satisfied this question. We have created a graph, we've identified our constant proportionality, and we've created our graph, identified our constant proportionality, and created a table. Okay. If you have any questions, please feel free to send me an email or comment in Google Classroom. Ask me whenever we come back to class, whatever it is that you may need for additional assistance.